Hello, my name is John Lyles, and I want to do my technology report on the ARM processor. This is a very common processor, but not very much is known about it. Before I was going to do a comparison between Intel and the ARM chip and why they're dominant where they are, but I didn't know, even myself, I didn't know much about the ARM processor. So I thought it'd be more interesting to talk about it with a few comparisons. Now, a lot of people have ARM processors that they use in their devices, but they may not know they actually do. Uh, Most likely because they just don't care. It's more important that their machine turns on, it works the way they want it to, rather than kind of what's going on under the hood. But the ARM Cortex A, which is the most common processor you're going to see in consumer electronics, as far as entertainment multimedia devices go, they're found in smartphones, tablets like the Galaxy Tab and the iPad, personal media players like the iPod, digital television set-top boxes, kind of like your Cox cable TV box, and many GPS devices will use the ARM processor to make it work. A lot of people don't know they're using ARM processor, but they might know some of the nicknames it gets. A few examples here. We have, especially with Apple's new release of the iPhone 5S and the iPad Air, they're touting their Apple A7X processor. Some HTC phones use what they call the Snapdragon processor. Some tablets use the NVIDIA Tegra processor, and then there's also the Texas Instruments OAM processor. Uh, those are all actually just nicknames for the ARM chip that have been modified by these manufacturers. Just like the Apple A7X, Snapdragon, Tegra, and Texas Instruments OAM chip, there are other ARM processors that are not using like consumer multimedia devices like the Cortex R and the Cortex M. And there's another one called Secure Core. Those ones, the Cortex R and M, are used for things that are in your everyday life, such as some automation in automobiles, such as logic sensors and such, and just sensors in general, motor controls. And then the Secure Core is a processor technology, licensed by ARM, developed by ARM, that is used in the SIM cards like you use in your smartphone that gives it its identity that it is your phone. Another nice thing about the ARM chip is because it's energy efficient, it doesn't create as much heat. Therefore, the devices like iPads and the Microsoft Surface RT tablets, um, they can contain that processor and be very powerful, machines. I mean, relatively, but have a really thin form factor, and a lot of that is because it doesn't need an elaborate heatsink system to displace heat in order to keep the CPU cool. So to talk about processor technology and energy efficiency, I actually am gonna make a comparison between the ARM processor and the Intel processor. The ARM chip uses, as far as its scale, for the silicon, it uses about 45 to 65 nanometer silicon tubes to make up the processor, and that is actually fairly large compared to Intel's latest release, which is the third and fourth gen Intel Core i5 i7s, which use a 22 nanometer process. Now, it's kind of strange to think why the one with the larger process would be more energy efficient, especially when Intel's keeps making their silicon smaller in order to gain energy efficiencies. And one of the big reasons is that the ARM processor is more energy efficient is because it has significantly less transistors per processor core than one of the Intel iCore processors. The Cortex A9 processor per core, I mean, it goes up to quad core, is 26 million transistors per core. Intel, the first generation quad core i7 had 731 million uh, transistors, and if you divide that by four, that was actually well over 182 million transistors per core. So, with all that going on, it is definitely using more power than that, even though it has a smaller process. Processor instructions are basically the operations that they carry out. The ARM processor is actually what's called an RISC processor, which is short for Reduced Instruction Set Computing. So therefore, it doesn't use a lot of different operations, but it's still capable of being a strong computing system, therefore requiring less transistors, therefore requiring less energy. Another important thing to point out about the ARM processor is the ARM's Holdings, which is the company that develops and owns the technology. Unlike Intel, they actually don't even manufacture the chips themselves. They just design the processor technology and then they license that technology to third-party manufacturers, like Qualcomm is one, Apple is one too, and Samsung. Although they're kind of different in the game because they have a special agreement with the ARM Corporation or ARM Holdings to actually develop their own chips and technologies. I mean, it's based on the technology. They still have to pay, the licensing fee, but they actually get to develop it rather than just getting the blueprint on how to make it and make it. One of the things that the ARM chip has been doing for a while, which makes it very effective, especially in portable devices, is it has something called system in a chip. And what they do is it allows for basically all the entire components that make up a computer to exist on a single chip. And you can see here from the graph, I mean, when ARM just leases out the technology and the manufacturer makes it, but then there's enough room on the die left for a lot of the things that would require a card or some sort of part on the system board of the computer. Those things include kind of the display adapters like the graphics and video or the graphics processing unit. Also controllers for USB devices and system peripherals. Actually, the RAM can be located on the die itself. External peripheral items, the input output for communications like modems. So these are some of the major points I wanted to bring up about the ARM processor is that it's a small, energy efficient, cost effective chip that uses a fraction of the transistors as desktop processors, but also have strong computing capabilities and the ability to contain all the things that make up a multimedia computer system all within the single chip die at a smaller size, allowing for your portable devices like your tablets and your phones to get even smaller and smaller and thinner.